Welcome to the YouTube channel of Unique World Education. Today we are going to discuss the next chapter, the grade 11 physics, motion in a straight line. In the previous video we have discussed about the units and measurement. We discussed about the questions from the chapter, the numericals. So in this video we are going to discuss about the numerical from the chapter, motion in a straight line. So before going to the question, let's have a brief discussion about what all things should be there in the chapter. So all the three equations of motion it should be in your mind as equal to ut plus half at square, v is equal to u plus at, and v square is equal to u square plus 2as. And most important, most of the questions are coming from the portion derivative. So you should understand how to take the derivative of something. For example, t square. What is the answer? 2t. What is the derivative of t cube? What is the answer? 3t square. And what is the derivative of the general expression n is equal to n into t raised to n minus 1. This is the main equation. Then you need to understand how to take the physical quantities from the graph. For example, if it is a displacement time graph, how to find the velocity? Velocity equal to slope of displacement by graph. You know it. I'm just giving you the things only. And if it is a velocity time graph, slope is equal to acceleration, means velocity by time. And if you take the area under the graph, you will get velocity into time, that is equal to what you will get, velocity into time, you will get the displacement. So these are the things we are discussing in the chapter. So directly we'll move on to a question. So we'll go to the first question here. Okay. A body is moving along a straight line according to the equation of motion x is equal to 2t square plus 10, where x is in meters and t is in seconds. Find its average velocity in the time interval t equal to 2 seconds, t equal to 3 seconds. First step, write the equation of motion x is equal to 2t square plus 10. Okay, we need to find the average velocity. So find the position of the object at 3 seconds first. Okay, it's very simple. 2 into 3 square plus 10, you will get 18 plus 2 into 9, 18 plus 10, you will get 28. Find the position at 2 seconds. X at 2 seconds is equal to 2 into 2 square plus 10, you will get 8 plus 10 is equal to 18 meter. It is the position at 2 seconds. Now you find the difference in the position, means what is the total displacement, or what is the total displacement means the displacement at 3 seconds minus displacement at 2 seconds is equal to 28 minus 18 is equal to 10 meter. Clear? And what is the total time taken? What is the difference in the time is equal to 3 minus 2 is equal to 1 second. Now it is very easy. What is the average velocity is equal to, what is the total displacement? What is the total displacement? It is 10 divided by what is the time? It is 1. What is average velocity? 10 meter per second. This is how we can find average velocity, find the total displacement, then find the total time taken. Next we'll find what is its instantaneous velocity. Here comes the derivative thing. So be in mind, whenever you are asking instantaneous velocity, instantaneous acceleration, whatever it is, instantaneous means at what position, at that instant what is the value of acceleration or velocity. Means the equation will be given in the terms of a t, and what at time instant t equal to 1 or 2 seconds, what is the velocity. So that is called the instantaneous velocity. To find the instantaneous velocity, we need to take the derivative of position. So I am writing it as 2t square plus 10, and velocity equal to, take the derivative of displacement with respect to time. You will get 2 into 2t plus 0, because the derivative of a constant is 0. You will get 4t. And we need to find the instantaneous velocity at 2 seconds. So here equation for velocity is 4 into t. What is the velocity at 2 seconds? 4 into 2 is equal to 8 meter per second. I hope this question is clear. Now let's move on to the third question. Okay, I will use some other color for the third question. Okay, yes. So what is the third question? Show that acceleration is a constant. For that, take the velocity. What is the equation for velocity? 4t. What is acceleration? Take the derivative of velocity with respect to time, you will get the acceleration. What is the derivative of t? It is 1. And what is the acceleration equation? It is 4. So just do the question by yourself and try to solve it once again. What we did, we found the position at 2 seconds, position at 3 seconds. We took the difference, we got the change in displacement, we got the actual total displacement it is taken, and we took the time difference, we got the total average velocity. Then we took the position equation, we took the final velocity, we took the derivative, we got the velocity, then we took the velocity at 2 seconds, then acceleration we created, and acceleration we got it as 4, and we can say that acceleration is constant. Acceleration is constant because it is not changing with the time, it is a constant value. Clear? Let's move on to the next question. Two balls are thrown. Yeah, very good question. Two balls are thrown simultaneously, P vertically upward with a speed of 20 meters per second from the ground. So first, two balls are thrown simultaneously, P vertically upward. So this is the P vertically upward with the initial velocity 20 from the ground, and Q, I will take another color for Q. Q is vertically downwards at a height from 40 meters with the same speed. So Q is dropped with the same speed at 20, and along the same line of motion, actually it is like this. P is in this direction, Q is in this direction. Q, this is P. And what they're asked, at what point the two balls will collide? So I'm just considering they will collide at this point, and I'm taking the distance that collide from the ground is x. So the total distance, the Q is at a distance of 40 meters. Then I am taking the Q will meet at the point at 40 minus x. Any doubt in this, you can just comment. So here once again, this is the point I took that the two balls will meet, and that position from the ground I took it as x, means the Q will have to travel 40 minus x to reach this point. Now this is very simple. Let's take this case as two different P. What is the initial velocity? 20. But what is the acceleration? Minus 10, because in the question they are asked to, you can take it as 10. For upward motion, ball is going up, but the acceleration is acting downwards. So acceleration we can take it as negative. And here we can take the distance traveled is x, because it traveling only the distance up to x to meet the second ball, and we can write the equation s is equal to ut plus half at square. So I am writing it as 20 into t plus half into minus 10 into t square. I got the answer as 20t minus 5t square is equal to x. I am marking it as equation number 1. Let's take the B part, that is Q part. Okay, what about the equations for the ball which is going down from the top? So the distance traveled by the ball is, I am writing it as 40 minus x. Initial velocity is 20 t plus half 10 into t square. Why? Because when the ball is going down, acceleration is also going down. So we can take the acceleration as 10 itself plus 10. In the first case we took the acceleration as minus 10, here we took the acceleration as plus 10, and we can write the equation once again. 40 minus x is equal to 20t plus 5t square, equation number 2. Now just compare the two equations, nothing, just add the two equations. So we can add the left side of the equation. So means 40 minus x plus x, we will get 40 equal to 20t we will get 40t plus 5t square minus 5t square will be cancelled, and we will get the answer 40 equal to 40t, and t is equal to 1 second. Clear? Good question it is. And we got the t, we can find the position. Take the equation number 1, x is equal to 20t minus 5 t square. Substitute the value of t equal to 1, you will get 20 minus 5 is equal to 15 meter. So at 15 meter from the ground, the two ball will collide each other. Clear? So here what the clue we have taken here, for upward motion of the ball we took the acceleration as minus, and for downward motion of the ball we took the acceleration as plus 10. And for upward motion, the distance traveled before colliding for the first ball is x, but the second ball it is traveling 40 minus x to meet the first ball, because that is dropped from the 40 meter height. This is how to solve this question. Let's move on to the next question. Very simple question it is. Position of a particle is given by x is equal to 3t minus 4t square plus t cube. Very simple question. Find the displacement when t equal to 4 second. So just substitute t equal to 4 second here in this equation. It become 3 into 4 minus 4 into 3 square plus 3 cube. So you will get the answer 12 minus 9 into 4 36 plus 27. So 27 plus 12 39 minus 36, you will get the answer 3 meter. Clear? So you will get the answer 3 meter for the first. Oh, I'm sorry, I made a mistake here. This is, I'm sorry. This is not 3 square. This is 4 square. 4 into 4 square plus 4 cube. You will get the answer, and you will get like, okay. So here it is 12 minus 4 into 16 plus 4 into 4 into 4. That is also 64. You will get, sorry guys, 12 minus 64 plus 64, you will get the answer 12 meter. I hope it is clear. You will get the answer 12 meter. Find the velocity and acceleration. So it is very simple. Find the velocity. So take the displacement equation 3t minus 4t square plus t cube. Velocity means take the derivative of displacement with respect to time. You will get the answer 3 into, what is the derivative of t? It is 1 minus 4 into, what is the derivative of t square? Everyone know 2t plus t cube. What is the derivative of t cube? It is 3t square. You will get the answer 3 minus 8 into t plus 3t square. 3 minus 8 into t plus 3t square. You need to find the acceleration. Take the derivative of velocity with respect to time. Once again, you will get the answer 3 derivative 0 minus 8 into derivative of t is 1 plus 3 into, what is the derivative of t square? It is 2t, right? And find the velocity and acceleration. Here this is the equation for velocity, and this is the equation for acceleration. You will get it as minus 8 plus 60. Here we can say that the acceleration is also changing with the time. So the acceleration is non-uniformly. Its acceleration is not uniform. So here we can say that is the motion of uniform accelerated. No, it is not uniformly accelerated. What is the reason? We can see acceleration is depending on the time, means it may change with the time. Clear? So what we did, it's a simple question. We took the position, we substituted the time, we got the position at the time. Then they asked for the velocity at the, velocity and acceleration. We derived the, we took the derivative of the position, we got the velocity, and we took the derivative of velocity, we got the acceleration. Okay, let's move on to the next question. The distance of a particle moving in one dimension under the action of a constant force is related to time. So here t is equal to root x plus 3 is given, where x is in meter and t is in second. Find the displacement of the particle. It is very simple question. Just listen very carefully. Here the equation is given in the term of t. So we need to convert this equation into the term of x. X is equal to root x is equal to t minus 3. And we can write it, just take the square on both sides. It becomes x is equal to t minus 3 the whole square. Now just open the bracket. T square minus 6t, 2 into 3 into t, 6t plus 9. This is the equation of position, equation number 1. Clear? We can take this as the equation number 1. Now find the displacement of the particle when its velocity is 0. So we need to find the velocity. How to find the velocity? Take the derivative of displacement with respect to time. So it is again take the derivative 2t minus 6 and substitute the velocity equal to 0, because we need to find the time at which velocity equal to 0. So just substitute velocity equal to 0. You will get 2t equal to 6. T equal to 6 by 2 is equal to 3 seconds is the time at which velocity equal to 0. We need to find the displacement of the particle when the velocity is 0. We found the time at which the particle, its velocity is 0, and the time is 3 seconds. Now we can find the position at 3 seconds. It is very simple. Take this one into here. Substitute the 3 in this equation number 1. So it become 3 square minus 6 into 3 plus 9. So you will get the answer 9 minus 18 plus 9. You will get the answer 0. Why? Because at velocity, at time t equal to 0, its displacement also become 0. Clear? So t equal to 3 seconds and you will get the displacement as 0. This is how to answer this question. Now let's move on to the next one. The position of a particle is given as then it is moving with. So first you need to find the position. It is 2 plus 3t plus 4t square. We need to find whether its acceleration, velocity, what is the characteristics of its velocity and acceleration. So take the velocity dx by dt is equal to, what is the derivative of 2? 0. Derivative of 3t? 3. What is the derivative of 2t square? It is 2t. You will get the answer 3 plus 8t. And again acceleration, what is that? Take the derivative of velocity with respect to time again. You will get the answer. What is the derivative of 3? It is 0 plus, what is the derivative of 8t? 8. So you got the acceleration as 8 meter per second square. And here acceleration is not depending on the time. So not depending on the time, we can say that it is uniformly accelerated. Clear? Okay. Let's move on to the next question. The motion of a particle along a straight line is described by, calculate the retardation of the particle when the velocity becomes 0. Very simple question. Calculate the retardation means acceleration. Okay. So position is given. We need to find the retardation. But when the particle velocity becomes 0. So take the equation of position 8 plus 12t minus t cubed. So find the velocity, take the derivative of position with respect to time. You will get derivative of 8 is equal to 0 plus 12 into derivative of t is 1 minus 3t square. Clear? T cube derivative is 3t square. You will get the answer 12 minus 3t square. And we need to find the retardation when the velocity becomes 0. So substitute the velocity equal to 0. You will get 12 equal to 3t square and you will get t square is equal to 12 by 3 is equal to 4 and t you will get it as plus or minus 2, but t we will take it only the positive value. We will get the answer t is equal to 2 seconds. Now we need to find the acceleration. How to find the acceleration? Because velocity equal to 12 minus 3t square, and what is acceleration? Take the derivative of velocity with respect to time again. You will get 0 minus 6 into t. Right. Now find the retardation at t equal to 2 seconds. Just substitute the acceleration as t equal to 2 seconds. 0 minus 6 into 2. You will get minus 12 meter per second square. This is how we can do this question. Okay, very simple question. Find the retardation at velocity equal to 0. What we did, we found the time at which velocity equal to 0. We substitute the time into the retardation or acceleration. We got the answer. This is a question I am giving you as a homework. Don't worry. So I will explain you how to do this question. Now you have to find the answer and comment the answer in the chat box. Alright, and I will give you the right answer in the next video. See, derive the equation velocity relation graphically. So that you have to do, it is given in the textbook. Graphically you have to find the distance velocity relation. You have to use a graph. You need to find the distance velocity. Distance velocity means which equation? X is equal to ut plus half at square. Right, or else v square is equal to u square plus 2as. So you need to derive this relation. Clear? So it gives you the velocity and distance and velocity relation. You have to derive this one, study this. I am also giving it as a homework. Now I am asking you to find the velocity time graph of an object is moving along a straight line is given below. You need to find the total displacement. And we know that if the velocity time graph is there, okay, whether it is any shape, if you want to find the displacement, we know that displacement is equal to velocity into time. So here y-axis into x-axis means it is the area under the curve. Area under curve. Clear? First, we can just split this equation or the question into two. First, you find the area of this triangle, then you find the area of this triangle again, then you can find the area of this rectangle. You know how to find the area of a triangle? Area of triangle is equal to half BH. For the first case, what is the base? It is 6. And what is the height? You need to find it. Or else you can just split the triangle into two and you can find the answer. But make sure when you find the area of the triangle below the x-axis, it should be negative. And here this is a rectangle, length into breadth. So try to solve this question as a homework and send me the answers in the chat box. This is how. Now let's discuss more questions on the next class. Okay, so we just discussed the basic questions only. For the coming classes, we'll be discussing more numerical from the coming chapters, also from this chapters also. Okay, thank you all. Try to watch the video 1 or 2 times and try to solve all the questions yourself, and do this question as a homework and send me the answers in the chat box. What is the total displacement? Means total area of the graph. Okay, thank you all. Bye.